Implementation of F-47 stealth technology by 2024, Overview of development phases and budget allocation. Introduction. The F-47 Stealth Technology Initiative marks a significant advancement in military aviation aiming for implementation by 2024. This program is backed by a substantial budget allocation of $3.2 billion designed to enhance the United States defense capabilities and maintain a strategic edge in modern warfare. This report outlines the key development phases, budget allocation, and the broader implications of the F-47 program. Key development phases. 1. Research and Design 2022 to 2023. The initial phase of the F-47 program commenced in 2022, focusing on advanced research and design. This stage involves collaboration with experts. The U.S. Department of Defense is partnering with leading defense contractors and universities. This collaboration aims to innovate materials and technologies that significantly reduce radar detectability. Stealth features. Key design elements are being integrated into the F-47 platform, including radar-absorbing materials and advanced aerodynamic shapes that minimize radar cross-section. Simulation and modeling. Extensive computer simulations and modeling are employed to predict the performance of proposed designs under various operational conditions. This phase is critical for establishing a strong foundation for the subsequent prototyping and testing phases. 2. Prototyping and testing 2023 to 2024. Transitioning from research to prototyping is set to begin in late 2023. This phase is characterized by prototype development. Multiple prototypes will be constructed to evaluate the F-47's performance, focusing on both aerodynamic characteristics and stealth capabilities. Testing protocols. The prototypes will undergo rigorous testing, including flight tests and simulated combat scenarios. These tests will assess their effectiveness in electronic warfare and low-altitude missions, ensuring they can operate effectively in contested environments. Feedback loop. Data collected from testing will inform design adjustments and refinements to improve stealth and performance metrics. The primary goal of this phase is to validate the design and prepare for large-scale production. 3. Production and Integration 2024. Once the prototypes have been thoroughly tested and validated, the program will move into the production phase. Manufacturing scale-up. This phase will focus on scaling up the manufacturing processes to produce the F-47 at an operational level. Avionics and weapons integration. Advanced avionics systems and weapons capabilities will be integrated into the F-47, enhancing its combat capabilities. Operational readiness. The aim is to achieve operational readiness by the end of 2024, ensuring that the F-47 can be deployed effectively in military operations. 4. Deployment and operational testing 2025. The final phase of the F-47 program will begin in 2025. Focusing on deployment in active service. The F-47 will be deployed within military units, providing enhanced air support capabilities. Operational testing. Extensive operational testing will be conducted alongside military personnel to ensure that the aircraft meets all readiness standards and integrates seamlessly into existing air defense systems. Continuous evaluation. Feedback from operational deployments will be used to make further adjustments and improvements to the aircraft. Budget allocation and economic impact. The $3.2 billion budget allocated for the F-47 program is strategically divided across various development phases. Research and design. A significant portion of the budget is dedicated to R&D, fostering innovation and technological advancements. Prototyping and testing. Funding for prototype development and testing is crucial to ensure that the aircraft meets its design specifications. Production and integration. Resources will be allocated for scaling up manufacturing processes and integrating necessary technologies. Beyond immediate technological advancements, the program is anticipated to create thousands of jobs in the aerospace sector. This job creation will stimulate economic growth and foster innovation within the defense industry, benefiting both the economy and national security. Common key points. Several critical themes emerge from the analysis of the F-47 program. Importance of stealth. The emphasis on stealth technology is paramount as it significantly enhances the survivability of the F-47 in contested environments. Collaborative approach. Success hinges on the collaborative efforts among military, government, and private industry stakeholders, ensuring a holistic approach to development. Timeline for milestones. There is a unified focus on achieving key milestones by the end of 2024, ensuring that the F-47 is operationally ready for deployment. Differences between sources. While most sources highlight technological advancements and budgetary aspects, some analyses delve into the geopolitical implications. Strategic capabilities. Certain reports emphasize how the F-47 will enhance U.S. military strategic capabilities against potential adversaries, reflecting the broader context of global military dynamics. Economic ramifications. Other sources focus more on the economic impact, particularly regarding job creation and innovation within the aerospace and defense sectors. Timeline of events. The following timeline summarizes the key events in the F-47 development initiative. 2022 – Initiation of the research and design phase, establishing foundational technologies. 2023 – Transition to prototyping begins with rigorous testing of the F-47's stealth capabilities planned. 2024 – Production and integration phase starts with a goal of operational readiness by year-end. 2025 – Expected deployment of the F-47 in military operations, accompanied by ongoing evaluations. Conclusion. The F-47 Stealth Technology Initiative represents a multifaceted project underscoring the importance of advanced military capabilities in the modern era. Backed by a significant financial investment and a clear development timeline, the program aims to enhance the operational readiness of U.S. military forces and ensure strategic superiority in the global arena. As the project progresses through its key phases, its implications for both defense and the economy will be closely monitored, highlighting the interconnected nature of technological advancement and national security. The content provided outlines a strategic initiative for the implementation of F-47 stealth technology by 2024, detailing its key development phases, budget allocation, and common themes across various sources. Here are some counterintuitive points that can be identified within the information. 1. High budget versus expected return on investment. While the $3.2 billion budget seems substantial for technological development, the actual return on investment may not be straightforward. The focus on stealth technology can lead to a situation where the benefits of increased stealth capabilities do not necessarily translate to direct combat superiority or economic advantages. The emphasis on achieving stealth may divert resources from other critical areas, such as countermeasures against adversaries who may also be investing in stealth detection technologies. 2. Collaborative approach leading to delays. The collaborative nature of the initiative involving military, government, and private sectors is generally seen as beneficial. However, it can also lead to bureaucratic delays and challenges in decision-making. The necessity to align multiple stakeholders' interests may slow down innovation and development, counteracting the urgency implied by the 2024 timeline for operational readiness. This aspect presents a paradox where collaboration, often viewed as a strength, may inadvertently hinder timely progress. 3. Focus on stealth technology over other combat readiness factors. There is a strong emphasis on stealth technology as a critical aspect of the F-47's design. This focus might overshadow other essential factors necessary for combat effectiveness, such as agility, payload capacity, and the ability to operate in multi-domain environments. Investing heavily in one area could lead to vulnerabilities in others, which may not be adequately addressed in the rush to achieve stealth capabilities. For job creation versus automation trends, the expectation that the F-47 program will create thousands of jobs in the aerospace sector is optimistic. However, the trend toward automation in manufacturing processes might counter the job creation narrative. As advanced technologies are integrated into production, there could be a reduction in the number of jobs available, particularly for low-skilled labor, contradicting the assertion that this initiative will significantly boost employment in traditional roles. 5. Geopolitical implications versus domestic economic focus. While some analyses highlight the geopolitical implications of the F-47 program, emphasizing its role in enhancing U.S. military capabilities, there is a counterintuitive notion that such technologies may escalate arms races rather than promote security. The program may lead other nations to accelerate their own defense initiatives, potentially destabilizing global security rather than ensuring it. 6. Operational readiness timeline versus real-world testing challenges. The ambitious timeline for operational readiness by the end of 2024 suggests confidence in the development process. However, real-world testing often reveals unforeseen issues that could delay deployment. The assumption that all phases will proceed smoothly overlooks the complexity of military technology development and the potential for setbacks, creating a disconnect between expectations and reality. 7. Integration with existing systems. The plan for integrating the F-47 into existing air defense systems may be more complex than anticipated. The assumption that new technology can seamlessly fit into established frameworks can be misleading. The integration challenges could lead to operational inefficiencies or require additional resources and time, contradicting the streamlined approach suggested in the development phases. These points illustrate the complexities and potential contradictions inherent in the ambitious initiative to implement F-47 stealth technology, highlighting that while the goals may be clear, the path to achieving them is fraught with potential pitfalls and unexpected outcomes. The report on the implementation of F-47 stealth technology by 2024 reveals crucial insights that may be overlooked by the general audience. Here are the key elements of the report that deserve attention, along with explanations of their significance. 1. Collaborative approach. While the report discusses collaboration between military, government, and private industry stakeholders, it is essential to recognize the depth of this collaboration. This is not just a partnership, it reflects a shift in defense strategy towards a more integrated and agile development process. By leveraging expertise from various sectors, the F-47 program can benefit from cutting-edge innovations in materials science, computer modeling, and simulation technologies. This collaborative model is significant because it can lead to faster development cycles and enhanced capabilities that may not be achievable in a siloed environment. 2. Economic impact beyond job creation. The $3.2 billion budget allocation is not solely about direct job creation in the aerospace sector, it has broader economic implications. The infusion of funds into R&D and manufacturing can stimulate local economies, foster innovation ecosystems, and lead to advancements in civilian technologies derived from military applications. This ripple effect is significant as it can lead to increased competitiveness in global markets, attracting further investment into the U.S. tech sector and potentially creating a cycle of innovation that benefits multiple industries. 3. Geopolitical implications. Many discussions around the F-47 program focus on technological advancements, but the geopolitical implications deserve greater attention. The development of stealth technology is a critical factor in maintaining air superiority and deterrence against adversaries. As nations increasingly invest in advanced military capabilities, the F-47 could serve as a countermeasure to emerging threats. The significance here lies in the potential shift in power dynamics as nations with superior stealth technology may gain strategic advantages, influencing global military strategies and alliances. 4. Timeline rigor. The timeline outlined in the report, particularly the rapid transition from research to prototyping to deployment, is ambitious. The significance of this rigor cannot be understated. It reflects a military imperative to stay ahead in technological advancements, especially in the context of rapid developments in adversarial capabilities. This urgency may lead to accelerated testing and deployment protocols, which could pose risks if not managed properly. Overlooking this aspect can lead to an underestimation of the potential challenges and risks associated with such a tight schedule. 5. Focus on stealth technology. The emphasis on stealth technology in the F-47's design is critical but may be taken for granted. Stealth is not just about avoiding radar detection, it encompasses a range of technologies including materials, shapes, and electronic warfare systems that work in concert to enhance survivability. The significance lies in the fact that advancements in stealth technology can redefine engagement strategies in modern warfare, allowing for operations in denied environments and changing the nature of aerial combat. 6. Operational testing and integration. The final phase of deployment and operational testing is often glossed over in such reports. This phase is significant because it is where theoretical designs are put to the test in real-world scenarios. The outcomes of these tests can lead to modifications that significantly alter the aircraft's capabilities. In addition, the integration of the F-47 into existing military frameworks is crucial for ensuring interoperability with current systems, which can impact the overall effectiveness of military operations. 7. Long-term sustainability and upgradability. The report does not delve deeply into the long-term sustainability and upgradability of the F-47 stealth technology. This is significant because as adversaries develop countermeasures, the ability to upgrade systems quickly and effectively will determine the F-47's relevance in future conflicts. The focus on initial deployment should also include strategies for ongoing development and enhancements, ensuring that the aircraft remains at the cutting edge of technology throughout its operational lifespan. 8. Potential for civilian applications. Lastly, the research and technological advancements resulting from the F-47 program may lead to civilian applications that could transform industries beyond defense. Innovations in materials, aerodynamics, and avionics may find uses in commercial aviation or other sectors. Recognizing this potential can broaden the narrative around defense spending, illustrating how military investment can yield benefits for society as a whole. Conclusion. The F-47 Stealth Technology Initiative represents a significant leap forward in military aviation, but its implications extend far beyond the technical specifications of the aircraft. By understanding the multifaceted nature of this initiative, including its collaborative development model, economic ramifications, geopolitical significance, and the importance of long-term sustainability, stakeholders can better appreciate the transformative potential of the F-47 program and its role in shaping the future of defense and technology. 1. Stealth technology importance. The F-47 program emphasizes the critical role of stealth capabilities in modern aerial warfare. Stealth technology is essential for enhancing aircraft survivability against advanced enemy radar and missile systems. The integration of cutting-edge materials and design innovations aims to minimize radar cross-section and improve electronic warfare capabilities, thus ensuring that the F-47 can operate effectively in contested environments. This point can be explored in depth by analyzing current stealth technologies, their implications on military strategy, and potential countermeasures from adversaries. 2. Collaborative development approach. The initiative showcases a multi-stakeholder collaboration involving military, government, and private defense contractors. This collaborative approach is vital for leveraging diverse expertise, resources, and technological advancements. Analyzing the benefits and challenges of such partnerships can yield insights into the effectiveness of defense procurement processes and innovation cycles. Discussing examples of successful collaborations in the defense sector as well as potential pitfalls could enrich the understanding of how the F-47 initiative can serve as a model for future projects. 3. Economic impact and job creation. the $3.2 billion budget allocation for the F-47 project is not only a strategic defense investment but also a significant economic stimulus within the aerospace sector. The project is expected to create thousands of jobs, fostering innovation and skill development. Delving into the economic implications of such defense initiatives, including job creation, technological spillover effects, and potential impacts on local economies, can provide a comprehensive view of the broader benefits of military spending beyond immediate defense needs. For geopolitical implications, the development of the F-47 stealth technology has significant geopolitical ramifications, particularly in terms of enhancing the U.S. military's strategic capabilities against potential adversaries. As nations invest in advanced military technologies, the F-47 program could shift the balance of power in global military dynamics. An in-depth analysis of how this initiative fits within the broader context of international relations, defense posturing, and regional security concerns can reveal the strategic motivations behind such advancements and their potential impact on future conflict scenarios. Here are three famous historical cases that reflect significant advancements in military technology and strategies similar to the implementation of the F-47 stealth technology initiative. 1. The development of the F-117 Nighthawk, 1970s to 1980s. The F-117 Nighthawk was the world's first operational stealth aircraft developed by Lockheed Martin. The project began in the 1970s with a focus on creating a fighter jet that could evade radar detection. The aircraft featured a unique design with angular shapes and radar-absorbent materials, which minimized its radar cross-section. The F-117's first flight occurred in 1981, and it was kept secret until its combat debut during the Gulf War in 1991. The success of the F-117 demonstrated the effectiveness of stealth technology in modern aerial warfare and influenced the design of subsequent stealth platforms, including the F-22 Raptor and F-35 Lightning II. 2. The Manhattan Project, 1942 to 1945. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. It involved a massive budget, extensive collaboration among scientists, engineers, and military officials, and rapid technological innovation. Led by the United States with significant contributions from the United Kingdom and Canada. The project aimed to create atomic bombs before Nazi Germany could develop their own. The successful testing of the first atomic bomb in July 1945 at the Trinity site in New Mexico fundamentally changed the dynamics of warfare and international relations. The lessons learned in project management, scaling up production, and collaboration among various sectors can be paralleled with the F-47 stealth technology initiative. 3. The Airborne Early Warning and Control AWACS Systems Development, 1970s. The development of AWACS systems, particularly the E-3 Sentry, marked a significant advancement in military surveillance and command and control capabilities. Initiated in the early 1970s, the program aimed to create an aircraft equipped with advanced radar and sensor systems capable of detecting airborne threats at long ranges and providing real-time battlefield management. The E-3 Sentry made its first flight in 1975 and became operational in the early 1980s. Its ability to integrate data from various sources and provide command and control in the airspace revolutionized military operations, demonstrating the importance of technology in enhancing situational awareness and strategic planning akin to the goals of the F-47 program. These historical cases highlight the crucial role of technological innovation, strategic collaboration, and substantial investment in military advancements similar to the objectives of the F-47 stealth technology initiative. Future outlook: F-47 stealth technology implementation by 2024. As the implementation of F-47 stealth technology progresses towards its operational target in 2024, several predictions can be made regarding the impact of this initiative on military capabilities, geopolitical dynamics, and the defense industry as a whole. 1. Enhanced military capabilities. The F-47 is expected to significantly enhance the United States Air Force's USAF capabilities in stealth operations. With advanced stealth features designed to minimize radar cross-section, the F-47 will likely perform better in contested environments, allowing for greater operational flexibility. Predictions suggest that by 2025 the F-47 will become a critical asset in strategic operations, particularly in regions where adversaries have developed sophisticated air defense systems. This could lead to a paradigm shift in air combat tactics, emphasizing stealth and electronic warfare capabilities. 2. Geopolitical implications. The deployment of the F-47 is poised to influence global military balances. As the aircraft enters service, it could provoke responses from rival powers, prompting them to accelerate their own stealth technology programs or enhance existing air defense systems. For instance, nations such as China and Russia may invest heavily in countermeasures aimed at detecting and neutralizing stealth aircraft, potentially leading to a new arms race focused on aerial capabilities. Moreover, the F-47's deployment will likely bolster U.S. allies' defense strategies, fostering increased military cooperation and joint exercises. This could enhance collective security arrangements, particularly in regions like the Indo-Pacific, where U.S. air superiority is vital for deterring aggression. 3. Economic impact and job creation. The $3.2 billion budget allocation for the F-47 project is expected to stimulate significant economic growth within the defense industry. Predictions indicate that thousands of jobs will be created not only in manufacturing but also in R&D, engineering, and cybersecurity. This influx of jobs could aid in revitalizing local economies, particularly in regions with existing aerospace and defense infrastructure. In addition, the technological advancements stemming from the F-47 program may have spillover effects in civilian industries, particularly in sectors focused on advanced materials, avionics, and unmanned systems. This could lead to innovation that benefits both military and commercial applications. 4. Technological advancements and future projects. The F-47 project is likely to accelerate innovation in stealth technology and related fields. As defense contractors and research institutions collaborate, breakthroughs in materials science, artificial intelligence, and sensor technology may emerge. These advancements could pave the way for future aircraft designs and military systems that further enhance operational capabilities. In the longer term, the success of the F-47 program may influence other military modernization efforts, potentially leading to the development of next-generation aircraft and unmanned combat aerial vehicles (UCAVs) that continue to push the boundaries of stealth and combat effectiveness. 5. Operational testing and feedback loop. As the F-47 enters the final phase of deployment and operational testing in 2025, a robust feedback loop will be essential for refining its capabilities. Real-world operational data will likely lead to adjustments in tactics, training, and even design features, ensuring that the F-47 remains adaptable to ever-evolving combat scenarios. Moreover, the integration of the F-47 into existing air defense systems will necessitate ongoing evaluations and updates, reinforcing the importance of agility in defense procurement and operational planning. Conclusion. The implementation of F-47 stealth technology by 2024 represents a significant leap forward in military aviation and defense strategy. With enhanced capabilities, geopolitical ramifications, economic benefits, and potential technological advancements, the F-47 is poised to redefine the landscape of modern warfare. As it transitions from development to operational readiness, its impact will resonate across military, economic, and technological domains for years to come. The success of this initiative will not only shape the future of air combat but also influence global defense dynamics and industry innovation in the years ahead.